Imagine two people communicating over a video call. One is an ASL user who is deaf or hearing impaired, and the other is an English speaker who doesn't know ASL. How can these two communicate with each other naturally and efficiently? Hello, my name is Dane, and in this project I will focus on identifying a particular type of gestures, American Sign Language. Lots of resources are available for translating between two oral languages, Google Translate being the most popular one. But when it comes to sign language, not many tools exist that are as accessible or responsive. Existing modes of bridging this gap are resource-intensive, put the burden of understanding on ASL users, or impede seamless communication. Coming back to our example, there are two directions of communication here that need to be facilitated. The signer must be able to understand the spoken words, and the speaker must be able to understand the signed words. For the first objective, we can assume that the signer is using a live auto-transcription software. The second objective is where this project comes in. The goal is to develop an ASL recognition system that can translate basic words and sentences from a video input of ASL in near real time. The system receives the video recording of the signer, interprets what is being said, and generates a written caption for the speaker to read. This process should happen quickly enough so that the two people can communicate without significant delays. The system architecture is as follows. First, the system receives a video input from either a media upload component or a live video source like a webcam. Once the video data is received, the system processes the data using MediaPipe, an open-source media processing tool developed by Google. The library has several modes, such as hand detection and upper body pose tracking, that will help parse out the locations and orientations of the skeletal joints. The processed data is then passed into the recognition model, which generates predictions based on the information. Finally, the predicted labels are converted into readable text captions and displayed on the screen. Let's talk more about the recognition model. This is the training dataset I will be using. The dataset contains video sequences of thousands of distinct ASL signs produced by native signers of ASL, along with annotations of those sequences. You can see an example of a video here. As is often the case for image and video-based machine learning, collecting enough data to train the model is an expected challenge. To counteract this, I will augment the data by adding noise to the processed joint data and reusing them, or flipping the video vertically if the gesture is symmetrical. This will yield more data from the same number of videos. Performance-wise, the minimum viable product for this project will be a system that can correctly classify individual ASL letters and static common words. With each iteration, the model should be able to handle more difficult inputs. The next step is to recognize dynamic common words, gestures in which the hand follows some trajectory. The ideal end model is one that can successfully translate longer phrases and understand some of the more contextual information, making use of parameters such as facial expressions and other non-manual signals. On the software side, the system will only accept uploaded video recordings at first. Once the recognition model can reliably classify common words and short dynamic phrases, the live video feed functionality will be incorporated. If time permits, I would also like to add a naturalization algorithm for the string of output words for a more natural sounding output. There are a number of related works with similar setups which use 2D image data or look for static gestures, so I will be referencing those as I build and test my model. The success of this project relies heavily on the recognition model actually working. In the unfortunate case that my model performance is terrible, the fallback plan is to adapt a pre-trained hand gesture recognition model such as the one found on Kaggle. As I am not a native ASL signer, evaluating the system will be a little tricky. The original dataset will be split into training and testing sets, and the quantitative evaluation of the system will be based on the model's performance on the testing data. For a more qualitative evaluation, once the webcam functionality is added, I will be learning some basic ASL words and sentences to be able to perform a high-level analysis of the system's UI and also stress test the video feed functionality. Thanks for listening. Any feedback is greatly appreciated, especially regarding the evaluation.